Second part of our Chapter 3 review test tomorrow. Are these angles adjacent angles? The answer to all of them is no. Angle 1 and angle 2 are not adjacent angles. Remember, to be adjacent angles, you must have the same vertex, which these angles do. But you also must have a shared side or a shared ray. Angle 1 is made with these two red rays. Angle 2 is made with these two blue rays. Angle 1 has its own two rays. Angle 2 has its own two rays. There's no shared ray. Notice there is a space in between these angles. If angles are adjacent, there would be no space in between them. They would be right next to each other like this. I'll make this angle 7 and angle 8. Those two angles are adjacent. Not these ones because there's a space in between. Adjacent angles also must not have common interior points. Look at angle 4. Point R is on the interior of it. Look at angle 3. Point R is also on the interior of angle 3. That's a common interior point to two different angles, so they're not adjacent. You could also argue that these two angles do not have the same vertex. That's another reason they're not adjacent. And number 22, angle 4 and angle 5, they don't share anything, so they can't be adjacent. Number 23, I'll use a highlighter here. We're talking about this big yellow angle. Is that adjacent with this smaller orange angle? They have the same vertex. They also share a ray. So the first two steps on your checklist are complete. The only problem is they overlap. The orange angle is completely inside the yellow angle. These are not adjacent angles. Next example, you have a big, huge picture with a bunch of angle measures. Then they give you words. This is not a good combination. Big, cluttered picture. Math words. Take your time. Make sure you know what they're asking you. Make sure you read. Name a pair of adjacent supplementary angles. Adjacent means next to. Supplementary means 180. Do you see two angle measures that are next to each other that add up to 180? I'm going to come over here to the side because I see a 62-degree angle and a 118-degree angle in the top of my diagram. So I'm just transferring over the names of these points. What are the names of the two angles that are next to each other that add up to 180? Okay, so here's the answer to number 24. Angle OTP and angle PTQ. Number 25, find a linear pair. Well, we just found adjacent supplementary angles. What is a linear pair? A linear pair are adjacent supplementary angles. So if you wanted to, you could actually give this answer down here as well. It's the same thing. Okay, now the issue with this is the test is multiple choice, which might make you think that it's easier. But what if this option that you already know is an answer isn't there? Then multiple choice is tougher. So you got to watch yourself. You need to find another linear pair potentially. Okay, well, I'm going to come down here to the bottom and I'm going to redraw my diagram. Remember how many times we did this in class? The most important angle in a linear pair is the straight angle. So here's your straight angle. Now if you want a linear pair, just draw another ray from your diagram that comes off of that straight angle. And then look at these two angles. Wouldn't these be adjacent supplementary? That's a linear pair. So again, lots of answers here, but this one works as well. Angle QTR and angle OTR. Number 26, find the measure of the angle that is supplementary to angle VTR. They're asking you for a measure. So be very, very careful here. We're not naming an angle. We're not finding an angle. You're giving a number. Supplementary to angle VTR. Find angle VTR. VTR. Angle VTR is 70 degrees. What's the supplement of a 70-degree angle? It'd be 110 degrees. Now, maybe you can find a 110-degree angle in that diagram. Maybe you can't. That might throw you for a loop, okay? There doesn't have to be a 110-degree angle up here. The answer to this question is 110, though. Number 27, name a pair of adjacent complementary angles. We need two angles that are next to each other that add up to 90. I see a 20 and a 70, and they're right next to each other. They share that vertex and that ray. Here's your two adjacent complementary angles. This is angle STV and angle VTR. Well, as you can see, Aaron Smith is calling me. I guess I better not pick up. Find the measure of angle OTS. He must not know what that little red dot means. It means I'm busy. Measure of angle OTS. That's this guy right here. What would its measure be? Well, if I take a second and redraw this diagram again, actually, maybe I won't redraw it. I'll just do this. That's a straight angle, 180 degrees. Here's an obtuse angle. This is angle OTS. I'm sorry, QTS. What is the measure of angle QTS? 50, 70, 20. That's 140 degrees. Your orange angle is 140 degrees. So what's left over for this other angle that goes right here? That's the measure of angle OTS. So it's 180 minus that 140. Okay, so if I would redraw it, it would look like this. You have a 140 degree angle there. What's the measure of this angle? These are a linear pair, so 180 minus 140 gives you that 40. Okay, last one. Name a pair of non-adjacent complementary angles. Now, I kind of did my best to really mess this picture up, but remember, that's a 40-degree angle. We just figured it out. The 40 and the 50 are complementary because they add up to 90, but they're not adjacent. They share a vertex, but they don't share a ray. So the 40 and the 50-degree angle are your non-adjacent complementary angles. Angle OTS. And angle QTR.